Hi, I'm Mr. V, and today's lesson is from the Illustrated Mathematics. This is coordinate geometry, and it's on functions, transformations as functions. So it's function notation. In fact, by the end of the lesson, you should be able to say, I can use coordinate transformation notation, which may be new to some of you, to take points in the plane as inputs and give other points in the plane as outputs. That's the big idea of what we're going to try to do today. And I'm making this video for people that are either absent or that want to go over what we did in class, but they want to do it at their own pace. So here we have, we're going to try to find the directed line segment from 0, 0 to 0, 2. Well, that's this segment right here, and it's going to go up this much. So if I apply that directed segment to this point, it puts me at a point that is located right here. The coordinates at that point are 3, 4. When you get it correct, I've programmed this to give you instant feedback so that you can understand that you got it right. Here, we're going to do the one from 0, 0 to negative 4, 1. Do you know your x coordinates and your y coordinates? That's going to be this translation in the x direction, this far. So the new coordinates here would be negative 1, 2. And when we go to the next one, it says to reflect across the x-axis. Let's see if I can make this bigger, make it a little bit where we can see it a little better. If we go across the x-axis, this is the x-axis. So I'm going to go across the x-axis. The two rules that it has to be across the x-axis, it has to be perpendicular to this, and it has to be the same distance on either side of it. The x-axis then, the line of reflection, would be the axis of symmetry. It has to be the perpendicular bisector of segment A prime. So the coordinates of this would be 3, negative 2. Notice the 3 stays the same for both of these. So it's reflecting across the x-axis, but the 3, that means I'm going to go the same distance in the x direction. It's the y values that change. And the last one that we're supposed to do is to do a 180-degree rotation about the origin. This is the origin. If we go 180 degrees here, we're going to go this far, much farther in this other direction. So I'm going this far in the one direction, this far in the other direction. And I get to this point, which is negative 3, negative 3. Not negative 3 only, negative 3, not 2, not 3, negative 2. It's going to be a negative 3, negative 2. A 3, negative 2 would be across the x-axis. When I change both of the signs, it puts me at 180 degrees rotation about the origin. That's my green check mark. Now let's see here. Transformation rules can be viewed as functions, which take a point in a plane to another point in the plane. And so far, we've written these out in sentences. I said, go from 0, 0 to negative 4, 0, or rotate it 180 degrees about the origin, or reflect it across the axis. But there's a way that we can do this with notation. And this is one of the notations I want you to consider. It says here, I start at xy. This is a point. And this arrow, we read that as maps to. So point xy maps to. And then they have this other point. It's going to be a coordinate. And the coordinates are defined. The x coordinate is defined as whatever the x coordinate was before minus 4. And the y is going to stay the same. So when we look at the first one here, we have 0, 0 going to 0, 2. The x's stay the same, and the y's were plus 2. So that is not the one here. That is not the function that would apply. Here, my x's, I'm going from 0 to negative 4. I'm subtracting 4 from what I started with. That's what we're doing here. And the y value stays the same. This is the one that matches up with this transformation. And further, when we do this one to the negative y and negative x, remember when we did just the negative y, we're just changing it, that would be flipping it over the x-axis. When we change them both, it makes it rotate 180 degrees. So that would be this last one. There is a synthesis here, a short video for you to watch. One thing that we'll see this soon enough. Now in this next section, we're supposed to plot these points, then apply this transformation, which is written in transformation notation down here, and find those new coordinates. When you find the new coordinates, if they're correct, you'll get a check mark here. So I'm just going to do this. I have negative 10, 5, which is here. So I can, negative 10, 5. Negative 4, 9. 9 is right here. And negative 2, 9. So this gives me this triangle, and I could label it ABC. Now we're going to find A prime, B prime, C prime by applying this to it. So for whatever the x value was, we're going to add 12 to it. Negative 10 plus 12 is 2. And for whatever the y value is, we're going to subtract 2 from it. So 5 minus 2 is 3. Okay. Now we'll do the next one. We have negative 4 plus 12 is 8. 9 minus 2 is 7. We have negative 2 plus 12 is 10. 9 minus 2 is 7. And when we plot these points, and I'll do this in a different color if I can manage it, we have 2, 3, 8, 7, 10, 7. And you'll see that I'm adding something or subtracting something from the x and the y. That's going to either move it horizontally when you add something to it, or vertically when you add or subtract in the y direction. It's all it's going to do is move it. This is a translation. This is the way that you would define a translation if these are going to be x's, pluses or minuses of any number to the x and the y. But the x and the y is not being multiplied by anything. It's not changing. And if I change the sign, making it a negative x, it's going to be a trans. We'll see that next time. Now let's do this one. We'll take our x value, multiply it by 2. Take our y value, multiply it by 2. So when I have a negative 1 times 2 is a negative 2. 3 times 2 is 6. I have a negative 1 times 1. Negative 1 times 2 is a negative 2. A 1 times 2 is 2. We have a negative 5 times 2. 5 times 2 is 10. 1 times 2 is 2. 5 times 2 is 10. Negative 3 times 2 is negative 6. And now we'll plot these. We'll plot the original points, and we'll plot these others. Let's do the originals. Negative 1, 3 is here. Negative 1, 1 here. 5, 1, 5, negative 3. This gives me some type of trapezoid. When I do the other one, I'll do this in orange. I have negative 2, 6, which is here. Negative 2, 2. 10, 2. And 10, negative 6. I get this trapezoid. And what you should notice by these is that this is a dilation. It's twice as long. Each of the sides are twice as long. And that's what we have a twice as long in the x direction and twice as long in the y direction. So we could find a point of dilation somewhere. It's probably right over here. Maybe it's the origin. I think it's the origin. And there's a synthesis video for you to watch. What does it do? This is where we go into the deep dive. And these are the transformations we're going to do, and we'll do each one of them separately. So let me make this picture here smaller so you can see it. First thing we have to do is list the coordinates of the A, B, C, D. So A is at 3, negative 1. B is at 5, negative 2. C is at 3, negative 6. D is at 2, negative 2. And then when we apply this transformation, the y values will stay the same, and the x values are multiplied by 2. So 3 times 2 is 6, and I have negative 1. I have 5 times 2 is 10, and I have negative 2. I have 3 times 2 is 6, and 6 is negative 6. Then we have 2 times 2 is 4, and a negative 2. When I plot these points, I get 6, -1. Here, I get 10, -2, 6, -6, and 4, -2. And what type of transformation is this? Is this a dilation? Before you answer that, answer the question, if this is a dilation, what is the point of dilation or the center of dilation? It is not a dilation. We are dilating in one direction. We are expanding in the x direction, but not in the y direction. And that is a little bit strange. It is not a dilation. If it were, both of these numbers, both the x and the y, would have to be multiplied by the same scale factor or scalar. Now let's do the next one. Notice these values stayed the same, so I left them in as green check marks. And here we go. We're going to the x value stays the same, and we're going to change the sign of the y. So we'll go 3, and the y from a -1 becomes a 1. I have 5, and the -2 becomes a 2. 3, and the -6 becomes a 6. 2, and then -2 becomes a 2. And when we plot these points, we get 3, 1, 5, 2, 6, 3, 6, and 2, 2. And this looks to me like it's a reflection over the x-axis. And if it's a reflection over the x-axis, then the y values would have to be changed, but the x values would stay the same. The last one that we do is this one. We're going to swap places with the x and the y. We're going to change the sign of the x. So my y value to begin with is -1, and if I change the sign of 3, I get -3. Here I start with a -2. If I change the sign of 5, I get -5. Here I start with a -6, and I change the sign of 3, I get -3, and start with -2, and I go to -2. When we plot these points, let's see what we get. -1, -3, -2, -5, -6, -3, -2, -2. And this looks to me like it's a rotation of 90 degrees clockwise about the origin. I wonder what it would take to be counterclockwise. Maybe we'll see that coming up in one of the lessons. If you get to page 18 and it's not correct, you can go back and check it. This is to see that it is correct. And we call this a dilation. No, this is not a dilation. Why? Because it doesn't have a point of dilation. It doesn't have a center of dilation. It's a dilation in one direction. This was the dilation that we had earlier. This looks like a reflection. Can you notice how it is defined by our rule of reflection? To be a reflection, you have to be perpendicular to the axis of symmetry. If the x-axis is the axis of symmetry or the line of reflection, we're perpendicular to it, going along the grid, sure. You also have to be equal distance. Those two things have to be in place. So A to A prime, or this point to this point, same with these other points. You have to be the same distance. There's a short synthesis video here and here. Lesson summary. And then we have this problem. This problem says you're going to go reflect this, x, y, change the value of the x. So if x is -2, x becomes 2. The y value stays the same. If y is 3, it's going to become -3, so it'll go over here. If b is 2, it's going to become a -2. It'll go here. And when I draw this, I get something like this. This would be a reflection across the y-axis. Notice the x values the y values stay the same, and the x values change. If you were to do it, there is a sort and a matching game, and I'm going to try to see if I can show you these in relatively short order. If I'm going to go from a -y to a -x, that would be this one. Here, my x's and my y's, I'm going to be rotating this 180 degrees about the x-axis. This is a rotation. That was the one that I think caught a lot of people by surprise. If I change over the x-axis, my y values have to change. Let's see. when I'm scaling, let's say I'm going, this is a transformation directly up, let's see, or down, going from the blue to the other one. Here we go, let's see, from the X, Y, Z, this should be Y plus 5, I think. I think that's a mistake. This should be, let's see, because we're going from the brown to the blue. So this will be here. And this one would be plus 6 and plus 3. And I'm left without 1. So I think this one is marked incorrectly. It should be plus 5. Otherwise, we're doing good. And the last thing is to tell me how you fared on what we did today. Give me some feedback on what you think about the lesson. Thank you very much, and have a good day. We'll see you tomorrow. Bye-bye.